It's very common in chemistry to start with something called a stock solution, so a solution that's relatively concentrated, and to dilute that down to the concentration that's required for a particular reaction. So in this section, we're going to look at dilution. How do we add more water to something to get the desired concentration that we want? If we start with a small amount of solution, represented by the diagram on the left, that has concentration of C and a volume of V, and then we add more water to it, or solvent, then what's happening to the moles? So in this diagrams, if I consider the particles of the solute, or the black dots, to be representing the moles that's dissolved, when we compare the two solutions on the left and the right, what you'll notice is that the number of moles, or the solute, is staying the same. So even when we add more solvent or water, the amount of solute, or the moles, remains constant. This will lead to a formula that we can use for dilution questions where we know the concentration and volume. So for dilution questions, when we're adding solvent, we want to consider the variables C1, the initial concentration, V1, the initial volume, and that together, multiplied together, gives us C2 and V2, the final concentration and the final volume. Now keep in mind that V2, the final volume, is the total once we've added more of our solvent. So we'll do a couple of example questions so that you can see how these will play out, or how to do these calculations. In our first one, we have 5 liters of seawater with a concentration of salt of 6.29 moles per liter. This is diluted to a volume of 35 liters. We want to now calculate the new concentration of the salt in our mixture. So the 5 liters that we have to start off with is our initial volume. That's how much we've started with. And the concentration of 6.29 moles per liter is the initial concentration. When it's diluted to a volume of 35 liters, that's giving us our total at the end of V2. So if we're looking for new concentration, that means that the unknown that we're solving for is C2. So taking the equation from above and rearranging to solve for C2, we would get C1 times V1 divided by V2. In this equation, as long as our units match each other, they don't have to necessarily match between the concentration and volume, and we'll see that in the next example. So for this one, all we need to do is substitute in our values. So our initial concentration was 6.29 moles per liter. Initial volume is 5.0 liters. And those two get divided by our final volume of 35 liters. So just type that into your calculator and you should come out with an answer of 0.90 moles per liter when we round for the two significant digits in the question. In this example, we're starting with a sugar solution that's 2.47 moles per liter. So that's our initial concentration, or C1. And that needs to be diluted to a concentration of 1.31 moles per liter. So we want to add enough solvent to get our second concentration, or final concentration, of 1.31. How much water should be added to 15 milliliters of concentrated solution to make the new concentration? So if we're looking for how much water, that means we're looking for a volume. We've started with 15 milliliters of our concentrated solution, so that's V1. The volume that we're looking for is not V2 because we're looking for the amount of water that was added. V2 is the total. So we're still going to go through our calculation to solve for V2, but then there's another step that we'll do to get the final answer. So if we want to rearrange and solve for V2, we're going to need C1 times V1 divided by C2. So our initial concentration of 2.47 moles per liter goes in. And now for volume 1, we have 15 milliliters. And even though the milliliters there does not match the liters that's part of our moles per liter, that's okay. We can still leave that there. C2 on the bottom is 1.31 moles per liter. And now the 2 moles per liter that we have on the top and bottom in our two concentrations are the ones that are canceling and giving us units of milliliters for the answer. So the fact that we left that volume in milliliters is okay. Our answer is 28.3 milliliters. And at this point, I'm just going to leave that extra digit because we have one more calculation to do. We want the volume that was added. And that's going to come from the total V2 and subtracting V1, the initial volume that we started with. So now the V2 that we calculated, the total volume of 28.3, we subtract initial volume of 15 milliliters, and that will give us the answer we're looking for. So this answer for two significant digits will come out to 13 milliliters. So make sure you're reading your questions carefully to know whether it's asking for the final volume, or if it's giving you final volume, or if it wants the volume that was added. If it's asking for volume added or it provides volume added, there will be one extra step in your calculation.